We're going to be doing more Wittig in this video. Now, following the same idea of nucleophilic additions to aldehydes and ketones with reactions that can create new carbon-carbon bonds, so increasing the size of the skeleton size of the molecule. Now, doing Wittig, we're making alkenes. So another type of problem that you will see is predicting products. So the previous video, we were planning synthesis. Now let's say that we have here the following compound. That and it gives me a sequence of reaction. First it says triphenylphosphine, and then I treat it with butyl lithium. Gonna draw the arrow here. And lastly, I am going to add acetone to that. So when we see that clearly, that's the strategy to make the Wittig. So if you were asked for the mechanism, the first step is a nucleophilic attack. So triphenylphosphine, that's an SN2 attack. This alkyl halide is primary and benzylic, so it's reactive, very reactive towards that. So the first step will create, after the nucleophilic attack, we will have this. Now, the second step here, treating it with butyl lithium. Here you have lithium is just a counter ion, and this anion is a conjugate base of butane, so very strong base. What this does is remove one of the two H's that we have here. And in doing so, we are making the halide. The halide is this compound that we have noticed nearby, the negative and the positive here. Triphenylphosphine. Next step, my advice to you is that you draw the resonance structure here to figure out what is that you are now adding to the carbonyl compound. So here you have your Wittig reagent. Once you have drawn that, you know that you will be installing all of that in place of the oxygen. Now I have this in the third step. We're making this react with acetone. So I'm going to draw acetone here. And if you have acetone, it's that. So what you need to do to predict products is in place of the oxygen, you put all of that. So I'm going to draw the product over to the other side. And let's see. Now I have this, and I will have that. So that is my halide. And I only have one product because fairly easy, because this is symmetric ketone. Not the same story when we have an unsymmetrical ketone. So I'm going to do another problem of Wittig in the same direction. Let's say now that we are going to make, this time, predicting products again. In this case, the first example that I did, we only had one product. Now here, I'm going to be doing a little bit different. Say that I do, this is 2-bromo butane, and I make it react with first triphenylphosphine, second and butyl lithium, and third, this time I'm going to use an unsymmetrical ketone. So this is acetylphenone, unsymmetrical ketone. So the first step is my SN2 reaction, and I'm going to do my nucleophilic attack over here, and that will create the following. Then this is step one, right? Step one, I make that. Step two, now I'm gonna have the strong base remove one each here. So we can, this is the H that we will be removing. So step two, you be forming now the following anion. Well, is a sweeter ion, is an Eli. So because we have a positive and a negative, right? So here we H3, and that has a positive, and I have a resonance structure, and in my resonance structure, I have this double bond. That is making my Wittig reagent. Now I make it react with acetophen. Notice that I am inserting, in place of the oxygen, I'm drawing that in. I forgot one carbon, and that makes all the difference in the world because that's what makes the ketone unsymmetrical. All right. Now let's draw the product. So in place of the O, I'm gonna put this part to make the alkene. So I can draw this, and I can also do it another isomer, and I can have that. So notice here, this is the E, and this is the Z, the isomers. So we have two products. So again, if we have, here we started from an unsymmetrical elide, unsymmetrical ketone, so I had two products. It was different than the previous example in which I had a symmetrical ketone. So pay attention to that when you're drawing your products.